Okey-doke. We're going to do the Unit 4 test review, problem 6. For the reaction of aqueous potassium phosphate added slowly to aqueous calcium chloride, first let's identify the type of reaction. Well, before we can even identify the type of reaction, it's going to help us to kind of look at it. So, potassium phosphate is K and PO4. And if you don't remember the charge on the phosphate polyatomic ion, you can use the solubility cheat sheet or the older polyatomic ion cheat sheet. It's PO4 with a charge of 3-. So potassium's in column 1 on the periodic table, so you know it has a charge of 1. PO4 has a charge of 3, so using the crisscross method, there's the compound. And we were told it's aqueous. Likewise, calcium chloride, aqueous was a given. Calcium is in column 2, so it's a charge of 2+. Chlorine is in column 7, charge of 1-. Crisscross method gives me CaCl2 as the compound. And they told us it was aqueous. So if I see a binary compound, metal-nonmetal, and another better binary compound, metal-nonmetal, my guess is it's probably going to be double replacement, where this guy winds up with the nonmetal over there, and this guy winds up with the nonmetal over there. They trade partners. So calcium phosphate will be one product, and potassium chloride will be the other product. Potassium and chlorine, or chloride rather, both have a charge of 1, 1+, 1-, so this compound's balanced as written. Phosphate with a charge of 3, calcium with a charge of 2. We do the crisscross, and we find that 3 calciums to 2 phosphates makes a balanced compound. And now we want to ask ourselves if these guys are soluble or not. Looking at the rule for phosphates, most phosphates are insoluble. The exceptions are group 1A and ammonium. Calcium's a group 2A, not a group 1A. Calcium doesn't qualify as an exception. This will be insoluble or solid. Chlorine, chlorides. We have a rule for chlorides. Chlorides are all soluble with these exceptions, but none of these exceptions are the case, so soluble is the outcome for KCl. So we have a solid and an aqueous, so it's definitely going to be a double replacement, and in fact it's going to form a precipitate of calcium phosphate. So, have we identified the type of reaction? Yes, it's double replacement. We've written a complete equation, including reactants and products. Have we balanced it? Oh, no, we haven't. Let's start with one of the metals. 3 calciums. Now it's 3 calciums. Putting a 3 here meant I now have 6 chlorines. 6 chlorines or chlorides. Probably want a 6 there. 6 potassiums. Well, I've only got 3 over here, so put a 2 out front. So now I have 6 potassiums. And now I have 2 phosphates. Oh yay, 2 phosphates. So it's all balanced. And if you need to, slow down and write out a chart with reactants and products for your different elements or polyatomic ions to double check. But this one's correct as written. So now we've written a complete balanced reaction, including reactants and products. State symbols are there. Balanced, did it. Ionic equation. Okay. Later we're going to write a net ionic. First, we're going to write a complete ionic equation. So a complete ionic equation is showing us which of these reactants and products separate into ions. And the rule is the aqueous ones or the soluble ones are what dissolve into ions. So a complete ionic reaction shows me that I have 6 K pluses, 2 formula units with 3 atoms per formula unit. Two phosphates, 3 calciums, and 6 chlorides. The solid isn't going to be split up. It's going to be combined as a salt or a compound. And here's 6 dissolved potassiums and 6 dissolved chlorides. Sorry if my handwriting is getting bad. I'm trying to cram this onto one line. So that's the complete ionic reaction. Now we identify the spectator ions. The spectator ions are the ones that are dissolved and ionic and free to move around in both the beginning and the end of this problem. Looks like it's the potassiums and the chlorides. G net ionic equation, and that's what's left after the spectators have been subtracted off or just ignored. So 2 phosphates, which were originally dissolved and free to roam around in the solution, and 3 calciums likewise, combined to make a solid and that's what happens. That's what truly reacts and changes after we ignore the spectators. Tiny add-on, I forgot to emphasize or write that there are 2 phosphates to make a balanced compound. Oops, now it's fixed.